Okay, so humans are going to walk on Mars, and we're constantly being told this isn't some distant pipe dream for a century from now or even 50 years from now. We're talking the next 10 to 20 years. I mean, we've got billionaires building massive rockets, global space agencies pouring in resources, and just a mountain of capital flowing into making this science fiction an actual reality. But before we get completely swept away by the romance of exploring the stars, let's take a look at a genuinely terrifying reality. If you were to step outside onto the Martian surface right now without a specialized, pressurized spacesuit, you wouldn't just hold your breath and freeze to death. Because of the utterly extreme environment out there, the water inside your blood would actually vaporize at your own body temperature. Your blood would literally boil inside your veins, and Mars would kill you in exactly 47 seconds. Welcome to this explainer. Let's dive right into this, shall we? We are looking at what is absolutely the greatest, most ambitious, and undeniably the most dangerous challenge humanity has ever attempted: colonizing an alien world. Today, we're going to break down the exact brutal realities of what a Martian colony actually demands. We're going to look at the facts, the timelines, and the immense hurdles standing in our way. Section 1. Why Mars? The ultimate backup plan. Now, people are always asking, why not just colonize the moon? Right? I mean, it's right there in our backyard, only a 3-day journey away. Well, the problem is, it's fundamentally barren. It totally lacks the basic building blocks you need for long-term self-sufficiency. Mars, on the other hand, yes, it's significantly farther away, but it has massive potential. It actually possesses critical underground water ice deposits. It has an atmosphere. Sure, it's incredibly thin, but it's there. And crucially, it's packed with rich mineral resources like iron and other metals. It's really the only planet in our solar system where humans might actually have the raw materials to build a civilization completely from the ground up. So the crucial takeaway here is that going to Mars isn't just some giant science experiment. For a lot of experts, it functions as humanity's ultimate insurance policy. Just look at the threats we face right here at home: rogue asteroids, global pandemics, the ever-present shadow of nuclear war. Our Earth, as amazing as it is incredibly fragile. If a civilization-ending catastrophe were to actually strike us, having a second, self-sustaining home on Mars ensures that human consciousness in all of our history doesn't just blink out of existence. It's literally our planetary backup drive. Section 2. 7 Ways Mars Kills You. The Brutal Environment. Let's start a rapid-fire look at challenge number 1, the atmosphere. Mars has roughly 1% of the atmospheric pressure that we enjoy here on Earth. Just 1%. This is exactly why your blood would boil if you stepped outside, like we talked about earlier. That catastrophic lack of pressure means our bodies simply cannot hold their internal liquids in a liquid state. Challenge 2 is the temperature. The average temperature on Mars is a freezing -81 degrees Fahrenheit, but it gets worse. In the depths of the Martian winter, it plummets to a pretty much incomprehensible -195 degrees. To put that into perspective for you, that is significantly colder than the absolute most extreme winter in Antarctica. At that temperature, basic equipment just fails, and standard metal becomes so dangerously brittle that it can literally snap. Challenge 3, radiation. So, Earth has this wonderful magnetic field that acts like an invisible shield, protecting us from the sun. Mars? It doesn't have that. The surface is constantly bombarded by harsh solar radiation that causes cancer and brain damage over time. To simply survive, colonists are going to need to live in underground habitats or construct walls out of Martian soil that are at least 2 meters thick. 2 meters just to block the radiation. Challenge 4 is the dust. Mars is infamous for these massive, planet-wide dust storms that can block out the sun for months at a time. And we aren't talking about normal dust here. It's ultra-fine, meaning it gets into absolutely every seal and gear, clogging up vital machinery. And worse than that, it's laden with perchlorates. Those are highly toxic chemicals that will severely damage human lungs if you inhale them. Challenge 5 is the sheer isolation. Mars is roughly 140 million miles away from Earth. That massive, mind-boggling distance creates a 20-minute communication delay. One way. Think about what that means. If a critical life support system fails or a sudden medical emergency happens, you cannot simply call down to Houston for help and get real-time advice, let alone a rescue ship. You are entirely, terrifyingly on your own out there. Challenge 6 is gravity. Living in 38% of Earth's gravity sounds like a blast, right? Bouncing around everywhere. But it is actually devastating to human biology. Your cardiovascular system degrades. Your bones weaken. Astronauts will lose up to 20% of their muscle mass in just 6 months, and that's even if they are doing rigorous daily exercise regimes.
And finally, challenge 7, the food. Growing crops in toxic soil with absolutely zero natural pollinators while relying entirely on artificial, power-heavy lighting is just incredibly precarious. A single agricultural mistake, a power grid failure, or a random crop disease literally equals total starvation for the entire colony.
Section 3, the master plan, how we actually get there. So, despite all those horrors, how do we actually pull this off? Well, we are currently watching a literal global space race unfold between 3 main players. First, you have SpaceX, driven by Elon Musk's highly ambitious vision to land humans by 2030 using their fully reusable Starship, which is designed to eventually transport 100 people at a time. Then you have NASA, taking a much more cautious, methodical approach. They're planning to build a base on the moon first as a stepping stone, which pushes their Mars timeline out by about 20 to 30 years. And then you have China, who is heavily investing in their own space program with a very firm target of putting humans on Mars in the 2030s. It is a genuine, high-stakes international race. Okay, so what does a realistic timeline for this actually look like? If we set aside some of the most hyper-optimistic claims for a second, experts generally project this decade-by-decade progression. In the 2030s, we might see the very first crewed landing, a tiny, brave pioneer group of maybe 5 to 10 people. By the 2040s, we expand that to a permanent base of around 20 to 50 scientists and engineers. In the 2050s, a small colony starts to form with over 100 people. But it really wouldn't be until the 2100s that we reach a truly self-sufficient civilization of over 1,000 people. And keep in mind, this entire timeline assumes absolutely everything goes perfectly, with no catastrophic disasters or major mission delays. Section 4, Remaking an Alien World, the 200-year vision. To truly conquer this world long-term, scientists are seriously considering something called terraforming. This is the sheer, unbelievable scale of human ambition required to make an alien planet Earth-like. The steps sound like pure sci-fi, but they're actually theoretically grounded in real science. Step 1 involves artificially pumping massive amounts of greenhouse gases and releasing asteroid ammonia into the thin Martian air. Step 2 is using all that newly trapped heat to melt the planet's polar ice caps. And Step 3 is allowing that thickened atmosphere to actually support liquid water on the surface. Over the course of maybe 1 to 2 centuries, we could theoretically create a world with oceans, breathable air, and green plants where humans could literally walk outside without a spacesuit. Section 5. The true cost. Astronomical logistics. $1 trillion. Let that sink in for a second. That is the staggering upper estimate for colonizing Mars over a 50-year period. And even on the absolute low end, we are looking at $100 billion. Now, private companies like SpaceX are definitely working tirelessly to reduce those costs. They're really hoping their reusable rockets can slash launch expenses by up to 90%. But make no mistake, colonizing Mars will still fundamentally be the single most expensive project in all of human history. Naturally, this immense cost brings us to a massive philosophical debate. On one hand, many folks argue that spending up to $1 trillion on a distant, dead planet is just irresponsible when Earth is facing immediate existential crises right now. Things like climate change, extreme poverty, and disease. That money, they argue, absolutely should be prioritized here. But on the other side, advocates strongly argue that we must become a multiplanetary species to ensure our long-term survival. They point out that the massive technological leaps required to conquer Mars in areas like energy, sustainability, and medicine will actually generate brilliant solutions that end up benefiting Earth immensely. Section 6. Humanity's next chapter. The psychological frontier. So, we've talked a lot about the hardware, but what about the human software? The mental health threat here is severe. You are taking a tiny group of people and locking them inside a highly confined underground bunker for 2 to 3 years of extreme isolation. How on earth do you manage human conflict in that environment? What happens when romantic relationships form or, break down? When the possibility of simply leaving the room, let alone the entire planet, is exactly zero. Furthermore, there's a huge question of who gets selected. If colonization is limited only to the wealthiest individuals or a single wealthy nation, we face some really profound ethical dilemmas about diversity and representation in humanity's next chapter. The absolute most crucial point to remember is this. For the very first pioneers who go to Mars to build those underground habitats and tend to those fragile greenhouses, there is likely no return ship. They are leaving Earth forever. They will work constantly in a brutally high-stress environment, and if all goes incredibly well and they don't die in some explosive accident, they will die on Mars, years later, of old age. So, understanding the boiling blood, the highly toxic dust, the absolute terrifying isolation,
And of course, the monumental importance of building humanity's backup drive. I have to ask you, would you do it? Would you leave absolutely everything you've ever known, everyone you've ever loved, and the beautiful blue skies of Earth behind? Would you take a one-way ticket to Mars? Really think about it. Thanks for joining me on this explainer. Keep learning, and I'll catch you next time.